S-Chan presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
What will happen when we are giving the waves to the strings? So when we are giving jerk to the strings, so there are the waves are producing on the strings. So these waves can be transverse, that means they can be in the perpendicular direction or they can be along the direction of the strings. So depending upon the direction of the waves, it can be divided into two ways. So firstly, I will explain you what are the transverse waves.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy. Myself, Dr. Narinder Kaur. So firstly, I will explain you what are the transverse waves. So now what are the transverse waves on a string? Firstly, what is a string? String is basically a knot or a wire which is tied up between the two ends. Now we are giving the jerk to that node. When we are giving jerk to that node, so what kind of waves are produced? So that can be explained like this. So now, if these are the two ends and a rope or a wave or a wire that is fixed up between these two nodes. Now loosen this end. For example, these are the two ends and these two ends are fixed. Now we are here losing this one end and apply jerk on this end. When we are applying jerk on this end, so waves are transversing over here. So that means, so such kind of waves, these are producing in the wave. This wave will travel from point A to point B. Now what is the kind of this wave? Now you can clearly see that the amplitude of this wave, or you can say the direction of this wave, is perpendicular to this. Now, firstly, originally, this is the string over here. Now, this is produced in the perpendicular direction. So, such kind of waves are known as transverse waves. When the waves are produced in the perpendicular direction to the string, such kind of waves are known as transverse waves. So, that means, for example, when the wire is fixed over here, we are applying some force to this end. That means we are applying jerk to this end. So waves are produced. That means, so it will form a crust, trough, crust and trough. That means where the amplitude is maximum in the upward direction. So this portion is known as crust. When the amplitude is maximum in the opposite direction, that portion is known as trough. So that means the highest peak, that means in the minimum, in the negative direction, again there is a highest peak. So such kind of wave is propagating from end A to end B. So this kind of waves are known as transverse waves. So that means the transverse waves are basically, now you can see that transverse waves, that means they are held to use a string to absorb the physical properties of the waves. That means now in order to understand the transverse waves, we can understand the physical properties of the wave also. So how you can produce it? For example, we are holding a one end of the string and the other end is secured. That means the other end is tightening up. So then we flick the string from one end. So that means the wave is transversed from one end to the another end. So such kind of wave which having direction perpendicular to. So this is the main point over here. That means the motion of the wave that is in the perpendicular direction to the direction of propagation of wave. Such kind of wave is known as transverse waves. So transverse waves are like that. That means the motion of the wave that is in the perpendicular direction to the string. So here the string is in the x-axis while the wave that is propagating in the y direction, or you can say that that is in the z direction. So that means if we are placing this string in the x direction and the direction of propagation of this wave that is along the y direction. Now if this is the y direction over here, then the direction of propagation that is along y axis, either in the positive y axis or in the negative y axis. So that means here the direction of propagation is in the positive y or the negative y. So such kind of propagation is known as transverse wave. That means the transverse waves are produced in the string. So these, when the direction of propagation is along the wave, so in such kind of waves are known as a longitudinal wave. So that we will understand later. So here the transverse waves are, that means the waves which are produced in the perpendicular direction. Now the wave is produced. So that means we are having a wave. So the wave is produced here like this. Now this wave must have some properties. So there is amplitude, the distance between crust to crust, there must be wavelength, there must be frequency, time period. So all these parameters are defined by defining the wave properties. So wave properties that can be defined as, now what are the wave properties over here? So the wave properties are defined as, now the transverse waves are the, what are these waves? They are having the peaks which are known as the crust and the troughs. So that means there are the maximas and minimas. So what is the maximum over here? That means the highest point on the peak. So that means if this is a wave over here, then this highest point of the wave, that is known as peak of the wave, or that is known as crest of the wave. That means this highest point, that is known as peak of the wave, or you can say that crest of the wave. While the lowest point, which are known as the valleys. Valleys means these are known as holes. If we are considering, so if this is a, that means, now if this is a wave over here, now the maximum point on this point here, this is a maximum point having the maximum amplitude. This maximum point, that is known as crest, or you can see that this is known as peak of the wave. So that is known as peak of the wave. Now this is a minimum point in the direction of propagation. This minimum point, that is known as valley, or you can see that they can known as a trough, or this is a hole basically in the wave having the minimum value. So this kind of wave, that is known as transverse wave. So that means the transverse wave, it are having the valleys, or known as a bottom point of the wave. Bottom point of the wave, that is known as trough, while the highest point of the wave, that is known as crest. So these are the properties of transverse wave. Now we know that the wave, it has some properties like amplitude, wavelength, and etc. Now what is the amplitude? So amplitude, it is known as, defined as the maximum displacement of a particle from its equilibrium position. Maximum distance from its equilibrium position. Now what is the meaning of equilibrium position over here? Now we know that in the starting, the wave or the string that is sided up between these two ends, so this position is known as equilibrium position. Now when the jerk is applied to this wave, when the jerk is applied, so the wave starts propagating from one end to the other end. So that means, so there is a wave in this string. So this is a kind of motion over here. Now this is a point B and here is a point A. Now this maximum displacement from the equilibrium position. Now if this is the equilibrium position of the wave, this maximum displacement, that is known as amplitude. So this is known as amplitude of the wave. And it is represented by the word capital A. So what is capital A? Or in some cases it can be defined by the word small a. So what is here over? This is known as the maximum displacement of the wave, and that is from the equilibrium position. So that is the important point over here. Now we know that this is also a displacement from the equilibrium position. Again, this is also a point. So if we are considering here 3 points, if one is a x, x1, x2 and x3. Now these are the 3 points over here. Now these 3 points have displacement from the equilibrium position. Now if this is the equilibrium position, now this point x1, it also has displacement from the minimum from the equilibrium position. x2 also has displacement from the equilibrium position, and x3 also has displacement from the equilibrium position. Now on comparing x1, x2 and x3, you can clearly see that here x2 is more than x1 and x3. So that this implies x2 is the maximum displacement of the wave from its equilibrium position. Here x2 is more than x1 and x3. So this implies this x2 point or x2 distance, if we are taking this distance over here, So that is known as amplitude of the wave. So this is a maximum displacement over here. So from the equilibrium position, that means this is the equilibrium position of the string over here. So this from this equilibrium position, again in the reverse direction, you can clearly see that when we are seeing this in the negative direction. So that means if this is a wave over here, which is produced. Now, if this is the maximum point, again in the negative direction, this is also the maximum point. So there is a maximum point in the reverse direction as well as in the forward direction. So this is the maximum point. Again, this is also the maximum point. Again, here, this is a maximum point over here. So all these points, these are known as amplitude of the wave, and it is always positive. Here, it is positive value. It also have positive value, but it is in the negative direction. Here, the phase is get reversed. We know that the wave, any wave, it is a combination of two factors. One is the amplitude and second one is a phase factor. So now this negative value that can be defined in terms of phase. Amplitude of a wave, it is always positive, either in the positive direction or in the negative direction. Means if there is a origin of the wave over here and we are taking y-axis here, and that is the x-axis or displacement with respect to time or with respect to distance over here. Now you can clearly see that this value of amplitude, that is always taken as positive. Amplitude is always taken positive for the wave, while this negative direction, that can be included or that can be defined in terms of phase. That means here the phase of the wave, that is positive. Now phase of the wave, that is changing from 0. Here is angle 90, then there is angle 180, 270 and 360 degree. Now, so that means from 0 to 180, the amplitude of the phase of the wave, that is in the positive direction. And from angle 180 to 360, that is taken in the negative direction. Now that means the complete wave that can be defined as A sine omega t. So the complete wave that can be defined by A sine omega t. What is A here? That is amplitude. Omega t, that is a phase of the wave. So now the phase of the wave, that is taken depending upon whether the knob or the crust is there or whether the trough is there. That means when in the positive half cycle, this phase is taken or it has a positive value, while for the negative half cycle, this phase have the negative value. So this implies depending upon the value of omega t, we can define or we can see whether the phase of the wave is negative or its amplitude. Depending upon that, its amplitude can be taken. So that means the maximum value of the amplitude, that is the maximum displacement from its equilibrium position, and that is taken always positive. What will be the lobe over here? Either in the positive half or in the negative half. So this is the wave and its direction of propagation, that is along the positive x-axis. So that means, and it is in the positive direction or it is in the perpendicular direction over here. So that means its propagation, no doubt motion of or the displacement of the wave or displacement of the string, that is along the x-axis, but its motion or the particles which are transversing energy from one end to another end, or they are transversing momentum from one point to another point, they are transversing this information along the positive direction or in the perpendicular direction. So this is all about the properties of the wave, in which we are discussing the amplitude of the wave over here. So now here we are taking a short break. So after the break, I will explain you the further the wave properties and how the wave is taken when and how we can define the speed of the wave along the string.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now before break, I clearly make understood you all what is the transverse wave and the property of the wave. Now, I will explain you rest of the properties of the wave and how the wave propagating in terms of a string. So now the wave property, so amplitude, it is defined as the maximum displacement of the wave. Now second property, that is a wavelength. Now what is the wavelength of a wave? So wavelength of a wave, that is denoted by the word lambda, and it is measured in terms of meter, centimeter or kilometers. In our case, when the wave is propagating from one end of the string to the another end of the string, so it is taken in terms of meters, and it is defined as the distance from either one peak to the next peak or one trough to the next trough. So that is known as wavelength. What is the wavelength of a wave? So if this is a string over here and the wave is propagating in the string like this, that means from one peak point, so this is a peak point in the wave, and this is a second, this is a trough, this is a peak point, again this is a trough. So that means the distance between two peaks. Now if this is a peak over here, second this is a peak over here. Now the distance between these two peaks, so that is defined as a lambda or wavelength. Again, the distance between these two troughs. So this is a distance between two troughs. This is also defined as lambda. So that means the distance between two peaks, this is also known as lambda, of the wavelength of the wave. And the distance between two troughs, this is also known as wavelength lambda. So that means in both of the cases, the distance, that means the wave propagating here as such that the information transversing from one end to another end at each and every portion is equal over here. So that means the distance between these two peak is fixed over here, and again the distance between these two troughs, this is also fixed, that is lambda. So in both of the cases, this is defined as wavelength of the wave. Now next term is what is the time period? So time period, that is usually denoted by the word t, and that can be measured in terms of seconds, because the information from one end to another end, the information is transferred in terms of seconds. So that's why the time period is taken in terms of second over here. So what is it is defined as the time which is taken for two successive peaks or one wavelength to pass through a fixed point. That means here we have to fix a point. That means when you are fixing a point, so if this is a point A in the string and this is a point B in the string and the jock is given over here, that means a wave is transversing from one end to the another end. Now fix a point C over here, or you can see that you can fix point at anywhere. So if this point C is fixed over here, then the time taken by the two peaks, now these wave will transverse or it will propagating along this direction. So that means this point C, that will be passed by this peak as well as this peak. So that means now the time taken by the two consecutive peaks. So these are the two consecutive peaks, that means one peak after the another peak. So when the time taken by these two peaks, consecutive peaks, the time taken by these two consecutive peaks to pass this point, this time is known as time period. So that means the time period means we are taking here consecutive. So this word is more important over here. That means these two peaks which are surrounded by or which are having a or trapping a one trough in it. Or you can see that these two troughs which are having a one peak inside them. So when these two peaks or these two troughs, the time taken by these two to pass the same point C, this is known as time period of the wave. So that means the time period of the wave, that is taken in terms of second. Now we know that the distance between these two peaks or these two troughs, that is known as wavelength. So the time taken by one wavelength to pass to the fixed point, to pass through a fixed point, that is known as time period. Now next point is a frequency. What is a frequency? Frequency basically defines the number of wavelength. So frequency, it is defined as the number of wavelength that passes through a given point in 1 second. That means now we are fixing the time over here. So that means, so in what is the difference between time period? So in the time period we are fixing a point. So point is fixed and the two consecutive peaks are passes through this same point. Now we are in the second case, when we are defining the frequency, we are fixing the time over here. So time is fixed here 1 second. That means in 1 second, how many peaks or wavelengths are passing through the one point. So that is known as frequency. So frequency, it is defined as the number of wavelength, that means the number of peaks, the number of 2 consecutive peaks or the number of 2 consecutive troughs which are passing to the given point. Point is fixed in 1 second. That means time is also fixed over here. So frequency, that can be measured by taking the reciprocal to the time period. So this is the term over here. So frequency, it is defined as frequency that is equals to 1 by t or 1 by the time period. So we are defining here the important terms which are defined over here. One is the amplitude of the wave, that is the maximum displacement. Second is the wavelength of the wave, that is the distance between 2 consecutive peaks or 2 consecutive troughs over here. Then T, capital T, that is defined as the time period of the wave. So that is defined as the when the 2 peaks or 2 consecutive peaks are passing to the given point, the time taken, that is known as time period. And second one is the frequency, that is known as number of waves which are wavelengths which are passing to the given point in the 1 second. So that is defined as frequency. So it is measured in the centimeter or meter, that is also its unit is meter, its unit is also meter, that is taken in the terms of seconds, while the frequency, that is reciprocal to the time period, and it is taken as per second over here. So this is defined as these are the few properties of the wave. Now next is how the wave travel. What is the speed of a wave on a string? Now we want to define speed of the wave. So at what speed, that means here if this the string is fixed over here, again the jerk is given to this string. So again there will be the wave which is producing from one end to the another end. Now we want to see at what speed this wave will travel to the string. So that can be, we know that generally we know that the velocity, that can be defined as distance traveled by the wave per unit time, that is known as time period, or that is known as speed of the string. That means speed, it is defined as distance traveled by the time it took to travel that distance. Means we are fixing the distance over here, and in order to cover that distance, but the time is taken by them, and dividing these two we will get velocity. Now in the wave, how you can define the distance? That means now we know that the wave is propagating from one end to the another end. So how we can define the distance? So distance of the wave, that can be defined in terms of wavelength. So that means here the distance is what? It is a peak between the distance between 2 consecutive peaks or the 2 consecutive troughs. So this is a distance between 2 consecutive troughs or 2 consecutive peaks. So that means in terms of a wave or any wave, we are taking a distance or displacement in terms of wavelength. So that means here the distance, that is equal to lambda. We know that wavelength, that is defined by the word lambda over here. So now the distance is equals to lambda. So velocity, what is velocity? It is a distance per unit time. Now what is the time for the wave? What is time? That is a time period. What is time period? So it is defined as the distance or the wavelength which is travelled by the wave in order to cross the one point. Means when the 2 consecutive peaks, they are crossing to the one point, that time is taken by them, that is known as a time period. So that means velocity, that is defined as lambda per unit time. So this is defined as velocity. So that is a wavelength per unit time. Now again we know that lambda per unit time, what is this over here? That is defined as a frequency. That means it is defined as a number of waves which are travelling to the given point. So that is defined as velocity. That means the velocity of a wave, that can be calculated by calculating, and when we know its lambda frequency, and second when we know its, so that means for a given wave, by measuring this point we can calculate amplitude of the wave. So that is the first point. Second, the distance between these two, that is known as wavelength of the point, that can be calculated. Third one, By calculating now lambda. From lambda we know that the frequency of the wave that can be calculated, time period that is known as in terms of t, and reciprocal of time period that is equals to frequency. Now what is the velocity of the wave? So velocity of the wave that is equals to lambda per unit time. Now lambda upon 1 time that is known as frequency. So by that means by using all these formulas we can calculate all these properties of the wave. So that can be calculated over here. Now if we are knowing the lambda over here, we can calculate its frequency also over here. So that means when the velocity of the wave is given and the wavelength of the wave is given, we can calculate its frequency also. So the frequency of the wave that can be defined as velocity of the wave divided by its wavelength also. So that means frequency of the wave that can be equal to its velocity divided by lambda. So now again we know that the velocity is taken in meter per second. Again lambda is taken in meter. So that means the frequency has a unit of per second. So that means the frequency of a string or the frequency of the wave that can be calculated over here. So these are the terms or these are the properties of the wave which can be calculated. So that means in case of a string, so these are the some important parameters, and the transverse waves, these are propagating in the perpendicular direction to the direction of propagation of a wave. So that means till now we have understood what are the transverse waves of the wave and what are its properties, wave properties, how we can calculate it, amplitude, wavelength, time period and frequency of the wave. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.